In this video, I wanted to talk about the algebra of functions and how combining functions together in different ways affects the domain and the range of the joined functions. So we generally refer to a function algebra as the operation of actually not like how we have in basic arithmetic, adding, subtracting, multiplying, dividing. If we're actually going to do that to different functions, we sometimes call that the algebra of functions. So, like for example, if we were to take f of x and add it to g of x, we often refer to that as a singular function, the sum function. And we're kind of going to examine the impact of joining those two functions together. And in a little bit, we're going to talk about transformations. And one other thing about actually combining functions together is it doesn't really work as simply as transformations do, which we're going to come back to that a little bit later. And when we subtract two functions, we refer to that as the difference function. The product function is when if you were to take two functions and multiply together. Again, shorthand, you would call it f plus g, f minus g, fg, just as multiplying. You usually don't put a symbol between them. And then the quotient function is what we call the net result of dividing those two functions, f of x divided by g of x. And again, this is like the shorthanded way of writing it. And you don't necessarily, like this notation can look kind of weird, and you might think it looks sort of distributive, but it's sort of like, well, this means f of x, this means f plus g of x. And again, it doesn't mean multiply, it's just a function notation thing, which looks kind of weird if you're not really familiar with it and used to it. And actually, the bullet points on the packet indicate how you would find the domain and range, but let's just look at an example and we'll kind of examine how those joint functions impact the domain and the range of each of those functions. So actually, let's start with question 2. It says, what is f plus g, f minus g, fg, and f over g when f of x is this and g of x is this? And then it asks us to find the domain of each. But let's just start with finding those four joint functions. So in this case, sorry, I need to fix my tablet because it is the wrong size. Okay, I think we're good to go. F plus g would just be, it's very obvious. And again, we would write it like this: f plus g of x is equal to, well, f of x was 1 over x plus 1, and g of x was the square root of x minus 1. And when I'm joining two functions together, you might wonder, well, is that it? And the short answer is yes, this is the combined function. But a lot of times we might actually want to figure out, well, what is the combination when we were to actually add those together? And now to add these together, you have to use legitimate algebraic steps. So reviewing intermediate algebra here, the only way we could actually add these together is with a common denominator. So if I actually wanted to do that, I would need to multiply this top and bottom. I could always put a 1 under this. Multiply this whole fraction by 1 over x plus 1, and then add it together. So actually, that's not that hard in this case, but to be honest, I just don't really want to do it. And the question is, well, what's the merit? Well, it would take two separate parts and put them into one combined function, and that might be simpler. In this case, I think it will just make it worse, because what I would end up getting is 1 plus x plus 1 times the square root of x minus 1 over x plus 1. And it's kind of an ugly joined function. But potato, potato, they're both correct. It's kind of like, well, which do you think is a better answer? It's a context thing. And I don't really care. So, and I think for the online homework, the examples I give you are not quite as horrible on the algebra side to try to figure out. Now, if we wanted to do what about the difference function, it's going to be exactly the same thing. Instead of f plus g, it's going to be, well, what is f of x minus g of x? Whoops, which is the square root of x minus 1. And again, the only difference here would be we'd have a minus sign. We could actually apply the distributive property as well and stuff. But as I said, I don't really want to do that, so we'll just leave it at that. And in this case, whatever, I'm just going to erase this. Good enough. Now the product function would be fg of x, or it would just be f of x times g of x. And we could just write them next to each other in algebra, or you could put them in parentheses or whatever, put a dot in between them to emphasize that we are multiplying those two things together. Now this one's a lot easier because if we have a fraction times a non-fraction, I will just multiply into the numerator, or you could put a 1 under it and do that. But this would just leave us with the square root of x minus 1 over x plus 1. So sometimes, you know, their combination might be quite a bit simpler, and it might be worth actually doing it. And lastly, the quotient function is just going to be the ratio of the two. So this would be f of x, which is 1 over x plus 1, then divided by g of x, square root of x minus 1. And remember, when dividing by a function, if it involves fractions, you can always use the flip and multiply rule in order to do that. So really what we'd have is 1 over x plus 1. We keep the first the same, and we flip and multiply by the second function. So it would be 1 over x plus 1 times 1 over the square root of x minus 1, or we could just write that as 1 divided by x plus 1 times the square root of x minus 1. We could use the distributive property or whatever, but at the end of the day, we come up with new functions. And each one of these, the whole point of this is we're joining them together using, you know, basic arithmetic, and it creates a new function. And there's purpose behind subtracting functions, multiplying functions. It's just sometimes in higher level math, we have these joined functions, and there's a quantitative reason for doing that. Just like, why would we normally add something? Well, for whatever reason we would need to. Now, all that being said, we could actually, once we have the joined functions, we could do things like evaluate them we could evaluate those functions at specific points. Like step 3 says compute f plus g, and so on, evaluated at 5. And that would just amount to, well, if I want to know what is f plus g of 5, it just would be plugging 5 into this function. But another way you could do it is you could figure out, well, what is f of 5, what is g of 5, and just figure out, well, what is f of 5 plus g of 5 separately. So you could calculate them as separate groups, or you could plug them into the combined function. Like in this case, if we were to look at f plus g of 5, well, if I plug 5 into f, that's 1 over 6. And if I plug 5 into g, that's the square root of 5 minus 1. Square root of 4 is 2. So I would get 1/6 plus 2, or 7/6 in that particular case. So I'm kind of writing this weird, but sorry, not 7/6. What was I saying? 13/6. And then if I was to do f minus g of 5, well, that would just be f of x minus g of x at the same point, which would be negative 11/6 instead. And then so on and so forth. Fg of x would just be 1/6 times 2, or if I'm looking at it like this, I could see that's just 2 over 6, which would be 1/3. And then f divided by g, again, if I have it over here, I could just use my algebraic simplification. And the point of actually doing the algebra is so that I could come up with a simplified function, which makes it easier to do the math. Which some cases it might make it easier, some cases it might be harder, but in this case that would be 1/12, because I would have 1 over 6 times 2. And anyways, you can approach it in either way. You could figure out what is f and g separately and then divide, and it's always equivalent, because that's the whole point of the definition. F plus g of x is always equivalent to the separate pieces combined. In the next video, we'll return to these examples, but we'll focus more on the domain and how that changes when we are combining these functions in different ways arithmetically.